Section 7.133. Suppose the birth weights of a full-term babies are normally distributed with a mean 3,800 grams and a standard deviation of 470 grams. We want to complete parts A through C below. For part A, we want to draw a normal curve with the parameters labeled. So what we want to do is we want to first identify the mean. Well, we can see that the mean represents 3,800 grams. So we have mu, which is equal to 3,800. And then we also know that the standard deviation, which is sigma, is going to equal 470 grams. So we know sigma is going to equal 470 grams. Number two, we want to determine the location of the inflection points. So in order to do that, we're going to take the mean and subtract the standard deviation, and then we're going to take the mean and then add the standard deviation. So the mean, which is 3,800, we're going to subtract 470 to get an inflection point of 3,330, and 3,800 plus 470 gives us another inflection point at 4,270. So now what we want to do is we want to be able to draw our curve. So the graph, we want to make sure it's symmetrical. So we draw a line. So you want to get used to drawing the bell curve. And therefore there is our bell curve. Okay, and then we know that the mean, or this is mu, is at 3,800. Okay, and then we know that there are inflection points. So we have an inflection point located at 3,330. And then we have another inflection point located at 4,270. So again, these are our inflection points. And then keep in mind that the horizontal axis represents the values of x. So therefore, here's the graph that has those inflection points. Okay, now in part B, they want us to shade the region that represents the proportion of full-term babies who weigh more than 4,740 grams. So I'm going to go ahead and copy this graph and put it down in here. Okay, and it says that we want to be able to shade the region that shows the full-term babies that weigh more than 4,740 grams. So what we're going to do is, since it says weigh more, we're going to locate here, so that's above 4,270. We can say it's probably somewhere around here. So there, we're going to find 4,740 grams. And then we're going to shade that. So that means we're going to shade everything to the right of that, because that represents everything that weighs more than 4,740 grams. So again, here we can notice that the graph shows that the region to the right of 4,740 shaded is shown here. And notice that 4,740 is 2 standard deviations away from the mean. Because what is 3,800? Okay, if we add the standard deviation, and recall that the standard deviation is 470, and that gave us 4,270, so that's one standard deviation. And then if we add another 470, then that's when we get 4,740. So therefore, this is 2 standard deviations away from the mean. Okay, now in part C, okay, what it's saying is that suppose the area under the normal curve to the right of x, which is equal to 4,740, is 0.0228. So that means that what they're saying here is that what's inside here is the probability, and that is a percentage of 0.0228, or we can say that this represents 2.28%. Okay, so what it says is that the characteristic described by the interval of values is full-term babies that weigh more than 4,740 grams. What that means is we have a probability of either 0.0228 that weigh more than 4,740 grams, or we can say that it's 2.28% that weighs more than 4,740 grams.